Okay, let's look at this question where we're talking about the state of California. Speed limits are established through traffic engineering surveys. One aspect of the survey is for city officials to measure the speed of vehicles on a particular road. So notice we're looking at strictly a particular road right now, and we're measuring the speed. So what is the population of interest for this portion of the engineering survey? So for this portion, we're looking at vehicles on a particular road. So our population is all vehicles on a particular California road. So again, remember to be specific. Okay, let's see. Then the variable of interest for this portion is the speed of vehicles, because that's what we're measuring. And since we're measuring speed, that is going to be a quantitative variable, because we can take the average speed, we can subtract the speeds, things of that nature. So now then, this question says for a qualitative variable. Well, we don't have a qualitative variable, so I'm going to mark that portion of the question out. For a quantitative variable, is the variable discrete or continuous? So speed, notice it says measure the speed, so that makes it a continuous because we are measuring the speed, so that is a continuous variable. Now, is a sample feasible in this situation? So on this particular road, we're looking at all the vehicles. Is a sample feasible? Yeah, population is probably not feasible. So yes, a sample is feasible, and you could do different types of samples. One of the easiest ways to do a sample is maybe a cluster sample. In other words, speed of all cars between certain times of day. You could also do a systematic sample and get the speeds of every 20th car, those types of things. So you could do a couple of different types of samples on this. Like I said, a population would be a little bit more difficult. Okay, we're looking at this graph over here, and we're talking about how people get their information. And so on this particular one, we want to identify the type of graph. Well, we have a bar graph. We have to pay attention. If these two bars had been switched, we would have had what is called a Pareto, because a Pareto goes from highest to smallest. But since these two are in the order that they are, this is strictly just a bar graph. What is the most frequent source of information according to the graph? Well, the most frequent, so if I go with most frequent, would be the internet. And then the least frequent is newspaper. How many more obtain their information from the television than radio? So here's the number from television. So there's 181. And then radio is 96, so we just subtract those. And that's going to be 85. So 85 more people obtain their information from television. What percentage obtains their information from newspapers? So when we're looking for percentages, remember we're going to put our total on the denominator, and then we put the number of newspaper on the numerator. So we're going to put 25 on the numerator, and then on the denominator, what we need to do is we need to add up all four of these values. So we're going to take 248 plus 181 plus 25 plus 96, and that's going to give us 550. So 550 is our total. And we multiply that by 100 to get the percentage, so times 100. And that's going to give us approximately 4.5%. Now let's look at this histogram. This is a histogram. Now remember, on the histogram, these are your lower limits. So this is lower limits here. So this first class, the lower limit is 18. The upper limit would actually be 22.999 type of thing. Okay. So the class width, remember class width is the difference between the lower limits. So we always take the difference between the lower limits if we already have our class limits. So I'm going to take 23 minus 18, which will give me 5. And if you'll notice, the difference between all of these is 5. So that's my class width. What class has the highest frequency? Well, we just go up to the one that has the highest bar. And then the class is starts at 18. And again, it doesn't go all the way to 23. It actually goes to 22.9. Because this is where the next class starts. The shape of the distribution, the shapes can be approximately symmetric or approximately bell-shaped. We can also have skewed left or skewed right. These are the three most common types. We can have what's considered approximately uniform. So when we look at this, the bell-shaped is going to come up and have a peak in the center. Left skewed and right skewed, you look at where the peak is and then where it goes off to, okay? So you look at where the majority of the data is, and it's going to be skewed on the opposite side. So which side does it go down to? So this one goes down to the right side. So this one is actually skewed right. So you're always looking, where are we going downhill to when you're looking at skewed? Which way are we going to the downhill part? Are we going downhill on the right or downhill on the left? Now we want to identify the lower limit of the second class. So here's class 1, 2, 3, 4, 5, 6, 7, and 8. And so the second class, the lower limit, is going to start at 23, because that's where the class actually starts. The upper limit of the fourth class, so we go to the fourth class right here, and we see, okay, the fifth class starts at 38, so this one is going to end at 37.9. because remember, it's not going to end at 38, it's going to end at that 37.9. Then we need to look at what percentage were between 28 and 32. So 28 and 32, that's this third class, so 25. We need to find out how many total there is. So we take 53 plus 44 plus 25 plus 30 plus 12 plus 16 plus 8 plus 1, and we get a total of 189. So we're going to have 25 divided by 189 times 100, and that will give us approximately 13.2%. Continue practicing and let me know if you have questions.